I'm Kaushal, and in this video, I'm going to walk you through my project. Every time you open Google Maps and look at restaurant ratings, you're seeing a simple average of star ratings. A place could have 4.2 stars, but every single review says cold food, rude staff, never coming back. People click 4 stars but wrote something completely different. What if instead of reading the stars, we read the actual words? In this video, I'm going to walk you through a full crate data pipeline which I built from scratch. It automatically pulls restaurant reviews from Google across an entire city, processes them with Apache Spark, feeds them through a BERT AI model that actually reads the review text, generates rank restaurant recommendations, and serves all of it through a REST API and live dashboard. I'll cover the full system architecture, the database design, and we'll run the entire thing live so you can see real data flowing through every layer. Let's get into it. I'll start the project with the Docker command. Till it runs, I'll just open the system architecture of the project. Okay, here's the full system architecture. It has 6 distinct layers. Each one has a very specific job. So you can see the 6 stages. Starting from the first, which is the source, we pull from the Google Places API, the nearby search and place details endpoints. For each restaurant, we get name, address, GPS coordinates, price level, cuisine type, and importantly, up to 5 recent reviews with the full review text. So this is the first source, which is from the Google. Then the second one is the orchestration. Apache Airflow sits at the center of everything. It schedules 3 separate pipelines that run in sequence every night, monitors every task, and handles retries. Think of it as the conductor. It doesn't do the heavy lifting, it tells everything else when to run and in what order. Third is the storage. So, two stores intentionally, like first is the AWS S3, which is our data lake. Every batch of raw reviews saved as JSON, our safety net to replay them. And MongoDB is the operational store, which contains raw reviews, processed reviews with NLP predictions, metadata, and recommendation. It's document shaped, so reviews nest inside restaurants and prediction nest inside the reviews. Fourth stage is the processing. As you can see, Apache Spark handles transformation. So it deduplicate reviews, clean the text, remove HTML tags, engineers features like review length, word count, day of week, and review age. Then it computes aggregate stats per restaurant, and it then outputs everything into a star schema format, like which is ready for the warehouse. After processing the model, which is the intelligence BERT model, this is where the BERT comes in, like a pre-trained BERT, like multilingual BERT model, which is fine-tuned on the Google reviews. So for every review text, it returns a predicted score from 1 to 5. Sentiment label, like from very negative to very positive as well. And also it has a confidence score. This runs separately from Spark because it's compute heavy. Then the last one is the serving. So a Flask REST API on top of MongoDB and PostgreSQL exposes endpoints for restaurants, reviews, recommendation, analytics, and personalization. On top sits the dashboard for visual exploration and pipeline triggers button. So a non-technical user can kick off run without touching the Airflow. So this was the brief about the system architecture. And Now let's talk about the database design. I'll quickly open the diagram for the same. This is where a lot of pipelines go wrong. Dump everything into one big table, and like if we do that, then our queries will get slow. That's why we use a star schema, like fact tables in the middle, dimension tables around them, like point of star. So I'll walk through each and every table. First is the fact table reviews at the center. So it has one row per review, and it's a text, the rating the user gave, the length, the word count. In addition, there's the age of the review as well. And this can be called as the measurable, like table which has the measurable attributes of a review event. Next is fact predictions. This is our second fact table. Like it's unique to ML pipelines. Every time BERT scores a review, that prediction gets its own row. So the predicted score, a sentiment label, the confidence, and model version kept, they're like kept separate, so we can like rescore with a new model tomorrow. So like we can write new rows without touching the original review data. So like we get the fresh confidence and other predicted values as well. Coming to the third table, which is dimension restaurant. So this has one row per restaurant, and it includes name of restaurant, address, GPS, then price levels, cuisine type, and also there's a column for like the Google's own rating, like that also will be stored. Mm, So like the price ID, like the place ID points back to the fact table, like as you can see in the diagram. This is connected via the place ID, and the fact to dimension has like n:1, and the fact reviews to dimension time is also n:1. So coming to the fourth table, which is uh, dimension time, like it has one row per unique date, like year, month, day, quarter, day of week, week of year. So like we can get the answers based on ratings by quarter or like most negative reviews by weekday by using a simple join instead of like writing complex queries. So coming to the joins, the analytical endpoint joins fact predictions to fact reviews for the rating, then dimension restaurants for the name. Like by this, like in one query, three tables are joined, and then like we get the instant answer from these three tables. Okay, now I'll go through the tech stack which is used, and also for this, primarily Docker is used. So the entire stack runs on Docker with 8 containers. I'll run a command to show the running Docker containers. So you can see the containers, like everything looks running. Here, like there are various containers. I'll go through it like uh, according to the hierarchy or something. Like uh, first one is the Postgres Airflow, like where Airflow its own metadata, which includes DAG definitions, task history, logs separate from our data. Then there's like Airflow web server and Airflow scheduler. So the web server gives us the UI, the scheduler watches the tags, and it fires the task. The next is the database, which is MongoDB, as you can see, and this is running on the port 27017, and it's our operational store. Next is the Postgres warehouse, and this is our star schema warehouse on the port uh, 5434, I guess. Yeah, yeah, 5434. And here the BERT predictions and review facts live for analytics. Next is the Spark master and the Spark worker. Like this is used for processing, and it's our cluster for transformation. Next is our front end, which is the Flask API and the dashboard on port 5000. So using the Docker Compose command, like I have ran this, and uh, in a single command, everything gets going or running. Now I'll open up the Airflow for the tutorial for Airflow. So this is the Airflow UI. It has 3 DAGs, 3 separate pipelines, all running on schedule. So I'll click on the ingest pipeline, which comes first. So the ingestion pipeline, like this is the ingestion pipeline. As you can see, you can look at this graph. Extract reviews, it runs first, like our Google API call across the locations which we provide. So this calls the Google API. Then the 3 tasks fans out in parallel, which is upload to S3, load to MongoDB, run Spark transformation, and Airflow manages that parallelism automatically from the dependency arrows like we defined here. Then like after once this Spark finishes the processing, load to warehouse runs, and that is the final step that writes clean transform data into our Postgres Postgres SQL star schema. And also the whole thing runs at like 2 a.m. every night automatically, so no human intervention is needed. So here's the last successful run. Every task is green, and once I click here I can see the logs as well. Right now the logs are like not working, so I'll trigger the pipeline again and then show you the logs in the later part of the video. So I'll give you some live data demo, and in this endpoint, like this is the health endpoint, and it gives a live count of every MongoDB collection currently. So we can see 886 reviews and the like 177 restaurants which were collected, and the pipeline ran across Tempe, Phoenix, and Scottsdale. I'll show you a few more endpoints. So this includes every restaurant name, address, GPS, rating, the price level, cuisine type, sorted by the Google rating and descending by default. If I choose top 10, this will be the top 10 like sorted by our BERT powered recommendation score. So it is a hybrid of AI sentiment, recency weighting, and popularity. This endpoint is where BERT earns its keep. At the top, like you can see the restaurants in the respective the Tempe, and it has the BERT score of like 4.85, and also like there's the average NLP score, which is a weighted score, which is 4.85. Then I'll show when a user hits a request or a post request for a specific Italian or like pizza, then what is returned for him, and he gives some minimum rating of 4.5. I'll open it in the command prompt. Okay. Mhm. Right now it's showing no preferences because the user is not been created. So I'll show this in the web app itself. I'll come to the front end. This is the front end of the web app. Like this is the dashboard. Everything we hit through the API is exposed visually here. Like it has search by name, filter by cuisine, then set a minimum rating, and the results update dynamically. So you can also trigger a whole new pipeline from here, and the run pipeline button, this calls the Airflow API in the background, like kicks off the ingestion DAG and pulls fresh data from Google. And the analytics tab pulls directly from the PostgreSQL warehouse. Those sentiment charts come from the start schema we just talked through. There's a NLP score for every restaurant, as you can see. You can just filter like the type of restaurant here, and you can sort it by Google rating or the AI score or NLP score. So here the NLP score comes from the model, the sentiment model. Plus, if you click on this card, you can see the reviews with the score, and also it has some label attached to it. And this is the AI score, which is like a weighted score. Like it's 0.5 into NLP score plus 0.3 into the recency, which is based on the time the review was given, which is like 0.3 into recency plus zero point 0.2 into the popularity of the restaurant. And this is the score which is from the Google, like the Google reviews rating. So this is the final score which we get, and uh, like it is out of 5. So max NLP recency or popularity can be max 5. So for one location, I can just click on run pipeline, and once the pipeline is triggered for a specific location, the results will appear after the run of the pipeline. So right now the Google API is doing a call to the Google Places, like Google Places API, and then that is stored into the S3 bucket. I'll show you the S3 bucket here. So this is the S3 bucket, which is the restaurant reviews lake. These are the raw reviews, and this is sorted according to the year, and this month is 6. So I have triggered the pipeline right now, and this is today's date. And as you can see, like nearby Tempe and like Phoenix area, the reviews are being pulled. And you can give any different location as well, and this is based on GPS, like your location, uh, the like it will take your longitude and latitude and then run the pipeline according to that coordinates. Suppose I want a cafe, so I can filter that on cafe, and I want like 10 top 10 according to the AI score, which is the weighted score. Just click on search and it will give me the top AI score. Like for few restaurants there won't be a recency score, but the other score like the NLP score will be available. So it will like calculate that based on the NLP score. As you can see, this has a good amount of rating. And if you want to check like or read some reviews, the reviews will be available here. And everything like will get updated every time the pipeline runs, or every night at 2 a.m. those pipelines which are NLP recommendation and review ingestion, they will be running. This is the NLP pipeline, and this will run the NLP and then save that to our MongoDB and also the PostgreSQL warehouse from where the dashboard will get its data. There's also a recommendation pipeline which I haven't shown you before. So this one like loads the data, then analyze and rank it, and then it stores the recommendation. So this is fetching the data right now, and you can see it's today's date, which is 29th of June. So I want to be honest about where this pipeline has room to grow, because understanding bottlenecks matters as much as understanding what works. So first one is the sequential API calls. Like I fetch details for each restaurant one at a time with the rate limiting. For 180 restaurants, it will be around like 3 to 5 minutes of pure waiting. And the fix is like thread pool, like using like 5 concurrent workers to cut out it under like 1 minute. Next is the smart Spark for small data. Like we use Spark to process like 900 rows, and JVM startup like it's around 30 seconds. So if I use pandas for this, it would do it under a second. But like Spark makes sense if I have like millions of records. So at this scale, like it's a bit overkill. But other positive thing about it is like it can like we can scale this 10 times without any code changes. The next bottleneck is the cold start of BERT. Like the model is like 700 megabytes and loads fresh from disk on every NLP run up to 60 seconds before like scoring a single review. So uh, for this dedicated fast API model server that keeps BERT warm in memory, and like this could save up some amount of time for the cold start. Next bottleneck is the unprocessed review lookups. Like in MongoDB, we find unprocessed reviews with like queries all over processed IDs. So at a million reviews, that list will be huge, and we can't use index. So there can be of like other property like a NLP processed flag, like a Boolean flag. So uh, using that will speed up the lookup as well. So this was about all the like bottlenecks which I found and which could be improved. So I'll just recap everything I walked through. So we discussed about the 6-layer data pipeline, like the Google Places API pulls live restaurant data across multiple cities. Then Apache Airflow orchestrates three DAGs that run automatically every night. Raw data lands in like AWS S3 as a data lake and MongoDB as the operational store. Then Apache Spark cleans and transforms everything into a star schema format. A BERT model reads the actual review text and scores sentiment more accurately than like raw stars. And a Flask API serves ranked personalized recommendations with PostgreSQL warehouse, like powering the analytics. And the entire stack runs on Docker Compose. Three commands, like you have to clone the repo, add your own API key, and then Docker Compose up. A full source, full source code is in the GitHub link. And if you want like me to explain the project in more detail about any Airflow DAX or the BERT thing, or even the Postgres star schema, just mention in comment. So if this was helpful, like hit subscribe, and in next video I can cover like more of my projects. And yeah, thank you for your time.